Good morning, good afternoon, and good evening. And thanks for joining us here at Texas Cybersecurity Summit. My name is Patrick Lloyd. I'm a Senior Solutions Architect with Cisco Security Services. And thank you for joining me for my presentation, Lessons Learned, Zero Trust for Segmentation and IoT-Based Smart Buildings. Let me start off with a brief introduction of myself. My name is Patrick Lloyd. I've been with Cisco Systems for about 11 years now. This presentation is a culmination of things that I've been working on with customers related to their zero trust journeys. And while I say smart building in the title, this doesn't necessarily mean that you must have a smart building to apply a lot of the lessons learned here, and I'll explain a little bit further into the presentation why. I've been very fortunate working for Cisco to be able to live all up and down the East Coast of the United States and travel all over the world. When I'm not traveling, you'll see in the center of your screen there, I have my Corgi, Luna the Corgi, who resides here with me in Cary, North Carolina. I also very much enjoy going to stand-up comedy shows, and on the left-hand side of your screen, you'll see me with a couple of my favorite comedians. Now, if you'd like to follow up with questions, comments, concerns, or to have a discussion around potentially working with you throughout your zero trust journey, on the top right-hand side of the screen here, you'll see a QR code. If you scan that QR code, it'll start up an email to me. Please feel free to reach out to me for additional information. So, let's talk a little bit about zero trust. And the question always comes up, why should you care? Well, zero trust and the phrasing of zero trust is pretty much like the Wild West at this point. Everybody means something different when they're talking about zero trust. And a lot of times what they're talking about is the implementation of a tool or something relatively simple that is tactical in nature that is meant to help secure your organization as opposed to meeting an overall business goal. What it really comes down to is when we talk about zero trust, we have to be focused on what the broader landscape of our business goal is. It's moving towards a whitelist method. It's starting with the idea of we need to understand what devices are currently residing on our network. Because let's face it, the greatest threat to our network right now are these little boxes that we have in our pockets, because everybody has one, and if we're not managing them, what do we know about them? On the topic of knowing more information about them, we also need to develop what I refer to as a contextual identity. That contextual identity consists of 6 things. Who is on what device, in what location? At what time, over what medium, and what vulnerabilities or threats does that device pose to our overall network? The only way that we can understand that is understanding what that device is and who's utilizing it, but also understanding what resources from the external world that device needs to consume in its daily operations. But we also need to understand how devices on our network interact with one another and develop some sort of baseline so that we can understand what the vulnerabilities are when they present themselves, or if that device gets compromised in some way, shape, or form. Now, if that device does get compromised in some way, shape, or form, we need some sort of vulnerability management, but also control point to prevent that device from infecting the rest of our network. We need to minimize the blast zone as much as possible. But all of this is only available if we have the robust tool set and analysis set to give us the ability to identify the signal within the massive amount of noise. The biggest challenge that we run into today is the landscape of security certainly isn't getting any smaller. It's a massive landscape that is only expanding by the day for vendors and products that will promise you zero trust capabilities. So therefore, let's jump into a little bit about definitions first. When I'm talking about zero trust, I'm talking about a solution. I'm talking about a set of products or a set of capabilities that allow for you to meet a business goal. The upgrade to a given product, the change in how we configure a given feature is not zero trust. Zero trust really needs to be how the set of a large number of products and capabilities play together to solve a business goal, like something like software-defined networking, like rapid threat containment. And when I talk about rapid threat containment, I'm referring to the automated ability to identify that a threat is on our network, identify what device and what user poses that threat, and then automatically quarantine however I want to do that, whether it be a VLAN, an ACL, or kicking them off of the network altogether with some sort of reject, to allow for me to take that device off my network without my administrators having to constantly be monitoring for those vulnerabilities. Now, when we talk about zero trust, I'm talking about a process, not a product. That process has been defined by many different vendors in many different ways. Cisco defines it as workplace, workforce, workload, and you'll see some references to that within the slides today. In the patent pending model that my team is working on, we're defining that as having an overlay. That overlay is typically some sort of policy and overall need to accomplish some sort of business goal, going back to that solution phraseology I was talking about before. Then being able to identify what endpoints play into that overlay, how they participate in that overlay, being able to enforce controls that we apply to those devices within the overlay, managing the vulnerabilities, and then analyzing how those devices are interacting with one another, gathering logs, and this becomes a cyclical overall process. Because let's face it, security is a journey. It's not going to be a destination. I'm not going to be able to secure the network to the best it ever has been. All I can do is work towards a more secure posture recursively to get me to the best place possible without completely shutting down the entire business and preventing it from doing business as usual. So overall, our ultimate goal should be to iteratively and recursively continue to secure our networks. So, if you remember nothing else from today's presentation, remember three things. Most of our customers have been working towards zero trust for years. And this is with simple mechanisms and simple application of inherent networking concepts to prevent devices from having a larger than needed blast zone, or being able to identify what these devices are with some sort of network access control product. Zero trust is an evolving process. There's always going to be new products, new capabilities, new features, new configurations that are out there. But what it really comes down to is, can I identify what those devices are on the network? And can I evolve what capabilities I have to then enforce and manage my overall vulnerabilities? And therefore, we start with visibility. We have to understand what devices are on the network, who is on them, where they're located, what medium, what time, and what vulnerabilities they pose to the network based on that information that we've gathered. So, let's talk a little bit about the journey, and by journey I mean let's talk about the customer in question here, because this is a real customer. We've codenamed them Smart Building Central. Smart Building Central had the ultimate goal of building out the next generation smart building. They wanted to implement connected elevators, the ability to call an elevator like an Uber, with an application on your phone to say, I'm currently at this desk via built-in blue dot navigation, and I need to get to the elevator. It's going to take me a certain amount of time, and therefore there's a calculation done on the back end to get that elevator to your floor as quickly as possible and make your overall working experience as efficient as possible. Dynamic lighting. Smart Building Central was in a very sunny area of the country, and therefore we wanted the ability to not only dim the lights inside of the classroom, like some of the smart home vendors out there, or dim the lighting inside of conference rooms when someone was presenting, but we also wanted the ability to dim the external windows as the sun came up or the sun went down, so that we could ensure that it was comfortable being in the building no matter what time of day. The built-in navigation that we talked about before, blue dot navigation to tell you if you have to go to this conference room for your next meeting, here's how you get there in the best way possible. All digital signage, moving towards a paperless goal. And then finally, guest hotspot capabilities. I've had CIOs and CISOs tell me, I believe that internet access for everybody who comes into my building is a birthright. And therefore, we want the ability to allow for guests to get onto the internet, but also utilize that ability to get onto the internet to present wirelessly so they never have to connect anything to their device. They just connect to a smart display, but we also need to minimize or eliminate nefarious uses of that capability as well. So when we talk about smart buildings, we're talking about as close to a at-home, fully controllable work experience as possible. We want the ability to sense what the environment is for our users. Is it too warm? Is it too cold? As people increase in a given area, how do we change the HVAC to ensure that our customers continue to be comfortable in that area? Automating that control and influencing the thermostat, influencing lighting conditions, etc. We also wanted to improve physical security because one of the most vulnerable pieces of any building nowadays is the physical security cameras. We'll talk a little bit more about that in some of the subsequent slides here, but just know that 15% of the worldwide malware outbreaks in 2019 were because of a connected camera. We wanted the ability to have emergency management through personnel proximity badging, using BLE or using connected badging to give us the understanding of who is in the building in the time of an emergency, and then also ensure that anybody still in the building is both accounted for and the digital signage can all be changed to guide those people to the closest and most available exit. And then finally, those cool little red-green light sensors like you go to the mall and you see to indicate where you could park, and even be able to pull that up on the app to determine where the most populated areas of the parking garage currently are. Because there's a massive benefit to this to our customers or to Smart Building Central. 35% energy reduction allows for Smart Building Central to be a better global citizen. It also allows for them to save on cost, with an 18% overall cost savings on energy by modifying lighting, sunlight, etc. within the building and ensuring that when the building is less populated, we can control the HVAC to bring that temperature up to a slightly higher temperature. It's a connected, intelligent, and secure overall building. But Smart Building Central was also had their own customers that they wanted to show what are the capabilities, what is the art of the possible, so that they could show off their products and how they interacted with how Cisco put this together to help them be as secure as possible within a zero trust model. So an overall increased sale goal as well. The problem is we know that risk is inherent to IT. We know that over the past 10 years, there's been over 300 data breaches involving the theft of over 100,000 records or more. And it's not getting any easier to detect when these breaches do occur. The average time to detect a breach is now at 206 days. Granted, that's down from a few years ago, but it's still a really long time to have a threat existing in your network and exfiltrating data on a regular basis. We know that there's an overall real estate investment that's being done here, $235 million, that could be a better proposition should Smart Building Central ever want to sell that building to another company. But there's also the average cost of the data breach that's $7.35 million per incident, which could offset that overall cost savings or offset the real estate gains that are made here. And let's face it, we don't want to be the next company on the front page of a given media outlet because of our records exposed. So Smart Building Central's integrations gave us the capability to identify, understand, and control how these given devices played into the overall environment and help secure the building as much as possible. But we started with one centralized question. Why is this such a challenge? Well, to understand why it's a challenge, we also have to understand how did we get here? In networking of yesteryear, the focus was always on connectivity over security, especially as you got higher up through reporting chain interactions. It's what we like to refer to sometimes as executive bling. I have this new device that I just bought that's hot off the press or hot on the market. I want this on the network. I want the ability to bring my smart speaker into the office. I want the ability to get my new tablet onto the network. I want the ability to have this smart whiteboard that I can interact with and I can show off to other executives and others within my company. So it was always get the device on the network and worry about securing it later. Focus on the centralized security point of the firewall to create rules for how this device interacted with the external world, but it created a massive blast zone. It essentially created IoT sprawl. All these IoT devices that are found all across our network that we don't necessarily know how they work on the network or what the true baseline of what success looked like for any of them, which causes issues of cameras reaching out to their controllers and now getting automatic downloads. Well, automatic downloads are fine when we're trying to send recordings to a network video recorder, but what happens when we can determine what the protocol that these cameras utilize to do that download are, and we exploit that with some sort of package that is sent in a corrupted firmware or something to that extent? So it comes down to trying to minimize dynamic discovery, which is becoming more and more popular across all the IoT devices out there, so that it's a zero-touch interaction for the administrator that introduces additional risk. It introduces jump-off points. And jump-off points all around the overall organization, no matter how you segment them off with VLANs, VRFs, or with firewalls. Connected cameras, for example, as I mentioned before, were 15% of the overall compromised IoT-enabled endpoints in 2019. And we only expect this to get worse with over 50 billion devices connected in 2020. When it comes to home routers and IoT connected cameras or network connected cameras, they made up for 90% of the malware infected devices in 2019. Having a process for how these devices are allowed to get onto the network and what access that they get is like having a cheat code. It's like having the ability to say, I want these things to occur and only these things to occur just by implementing an overall process. Because let's face it, we have a new generation of workers, devices, and workloads all coming into our premises and accessing our networks even remotely. So let's talk a little bit about Smart Building Central's base requirements, because they represented most customers that I work with. It was a relatively simple, or supposedly relatively simple, implementation. 500 users, 3 to 4 devices per user. Think a PC, a voice over IP phone, a mobile device, a corporate tablet. And then we can factor in there printers, HVAC devices, etc., as equaling out the average of user to user who doesn't have one device or another. We knew that they would have IoT and industrial control systems and backnet translation devices to interact with HVAC, with thermostats, etc. We talked about the guest proximity, but they also wanted unparalleled analytics. How secure are we? How do we move away from security as an investment and justify that investment with statistics about what was blocked, how it was blocked, where it was blocked? Because we know that risk is going to be inherent to IoT, and we want the ability to categorize and quantify what that risk is. Now, we knew that we'd have a number of challenges with Smart Building Central, and then we had some unknown challenges as well. The known challenge, well, IoT as a lateral attack vector. What we didn't take into account is some of those IoT devices were not necessarily RFC compliant. For example, if we do 802.1x to authenticate a device onto the network, even utilizing MAC authentication bypass, there's the expectation that if a device is queried for its credentials and responds back with, yes, I have credentials, it will also send those credentials. And what we found is with some of these devices, they would respond back with, yes, I have credentials, and then shut down, which caused the devices to remain unauthorized and gave us little visibility into what they were or how they were interacting with the network until we restarted them and started the process all over again. In addition, there are a number of unattended media devices or digital signage throughout the building, essentially just a microcomputer with a presentation that was playing on it. And that microcomputer had to be network connected, and even though it was VRF'd off, and even though it was segmented, we wanted the ability to ensure that these unattended media devices didn't become jump-off points and didn't disseminate any proprietary information to Smart Building Central to the outside world or to a nefarious actor. So the question came down to, how do we do it? And the basis behind that is, if you knew that you were going to be compromised, would you do security differently? Every customer I've ever worked with, when asked this question, the answer is always the same. Absolutely. But how do I get started? Well, let's talk about how you get started. Now, being a Cisco services engineer, I do want to make brief mention here of Cisco services in our approach. When we implemented Smart Building Central, we came in with our 3 major pillars of Cisco services. We wanted the ability to plan out what this would look like. That included program strategy, understanding what the overall goals were, doing the architecture and design, and then afterwards assessing what that overall architecture and design resulted in, penetration tests, security best practice reviews, etc. Then we built this out with Smart Building Central, doing the integration into the application systems, into HVAC, into the networking overall environments, migrating off of older applications into new applications, or migrating policies from old firewalls and segmentation strategies into newer methodologies. And then optimizing, ensuring that the right versions of code, best practices were followed, etc. were all present within Smart Building Central. And then the key differentiator here is Cisco Managed Services. Cisco Managed Services manages the entirety of Smart Building Central. All adds, changes, and deletes we are responsible for, and the customer entrusts us to keep them safe through managed security, hosted security, and overall product support. They never have to call TAC themselves. All they have to say is something isn't working. Cisco Managed Services manages the entire portfolio for them. So let's talk about the practicals. Let's start to layer on what this looks like in the overall methodology, like Lego blocks. Let's build an architecture. As I said before, Zero Trust has been described in many different ways by many different companies via many different models. One of the most familiar models is the Google Beyond Corp implementation of Zero Trust. The Google implementation of Zero Trust follows a lot of the same concepts that we've been talking about here. Securely identify the devices, going back to contextual identity. Securely identify the user. Remove trust from the network, moving towards more of a whitelist approach as opposed to a blacklist approach. And then externalize apps and workflows while implementing inventory-based access control. Cisco describes this as workforce, workplace, workload. What is in my building? Are they in my workplace? How did they connect to the network? And then how do I ensure that they are only interacting with the network the way that I expect them to? As I mentioned at the top of the presentation, I'm currently working as part of a team to develop a patent pending model for how Zero Trust is implemented in these sorts of scenarios. This is that overall model. We have an overlay. That overlay is understanding what my policies, motivations, and challenges are going to be from the onset. Understanding how this device is going to have to be overseen in the network and what challenges we're going to have around operational capabilities, administration capabilities, and troubleshooting capabilities. What policies do I have that either allow or restrict the access that that device has? Now, I need to identify that device, or what I'm referring to as that entity. And that entity is a device with potentially a user on it or possibly not. IoT devices won't commonly have a device on them. Can I assess this entity for risks it poses to my network with vulnerability management? Can I determine what its baseline is, what ports it has open, and if it has ports that are open that shouldn't be, or that pose a significant threat to my network, think unsecured FTP or SMB version 1, how do I prevent those from being exploited in some way, shape, or form? And then enforcing that capability. Can I allow or prevent that access with the knowledge and the baseline that I have? All of this continues to be analyzed at every step to feed that information back into overlay, and again, cyclically follow through the overall process again, especially when it comes to purchasing new devices or new devices that are found on the network that we may not expect them to be there. So let's talk about the security path, because there's no doubt in my mind there's questions out there about, so how in the world do I do it? Because, hey Patrick, I'm not a one vendor shop, and you don't have to be. What this comes down to is following the same model with the products and capabilities that you currently have available to you. While Cisco has an alignment to every one of these capabilities with some sort of product, it can also be done with other products on the market. So when it comes to something like determining identity and determining that baseline, evaluating based on that visibility that we need into the network, well, we need to establish that visibility with a set of products to form an overall visibility solution. When it comes to my workforce, for Cisco's product alignment, we're talking about Identity Services Engine. We're talking about utilizing Radius to authenticate, authorize, profile, and do posture evaluations of what that endpoint looks like to the overall network. Also integrating into things like mobile device management platforms. We need the ability to understand what our remote workplace visibility and monitoring looks like as well. Do we have the ability to identify a device even if it's not on our network, even if it hasn't plugged into one of my native switches or into a wireless LAN controller? Do I have the ability to determine what that device is based on how it's interacting with the network? And then, once I identify it, do I have the ability to gain visibility into how it's interacting with my network overall, with things like network visibility, as well as providing my managed devices with a trusted network detection capability? I need to understand how it interacts with the outside world through DNS monitoring, for example, so that I can understand what the malware on the network looks like, where it came from, based on a device possibly accessing a website that spun up just mere moments ago and being somehow redirected to that website through cross-site scripting or overall phishing attacks. As devices connect into my network while in my workplace, I want to understand how those devices interact with one another. One of the best ways to do that is through NetFlow. NetFlow gives us the ability to understand what is contained within the headers, within the flow, ports, protocols, etc. And then in my data center or in my virtual workload, I have the ability to utilize tetration to understand how these devices interact with a virtual server that may not be possible with some of the standard monitoring techniques. Because, as I said, we need that contextual identity. We need to understand everything about this endpoint and what threats it poses to my network. The way that we used to do this was just with an IP address or just with a MAC address. That IP and that MAC combination don't mean much when MACs are very easily spoofed and IP addresses go away after 8 hours or whenever we unplug the device and plug it in somewhere differently. If we have an overall campus with thousands of devices and a massive DHCP pool to enable their access, we can't necessarily write control rules to prevent those devices from interacting with the outside world unless we get as close to the device as our control capability allows us to do so. And therefore, we need to understand who is on that device, where it's located, what that device is, what access it's being granted, what medium it's coming in over, and what the threats and vulnerabilities to our overall network are, so that we can apply that control as close to the endpoint as possible. Now, by this point, you're probably sick of hearing me say identity, visibility, identity, visibility. But at the same time, I think that also reinforces how important identity and visibility is to our overall network. It truly is the keystone of securing a smart or zero trust based implementation. And we need to understand what access should this user have, but that comes from knowing who the user is. What role does this user have, and therefore what access should we give it? What is it accessing? Where are they trying to go? Who is on the machine currently, especially if it's a shared machine with multiple accounts, etc. The next step of this is the ability to control based on that identity. We need the ability to enforce and ensure that we can prevent that device from interacting with other areas of the network that we don't want it interacting with. We can do that with a number of different products or different capabilities. We can do that with a downloadable access list, an automated push of an access list based on what that device looks like and what its contextual identity is on our network. When we determine that malware is out there, that malware protection application can also prevent that device from interacting with the rest of the network until it determines that that malware is no longer present. We can manage mobile devices in these little boxes in our pockets with some sort of mobile device manager, and then our corporate machines with an endpoint manager. We can also now detect what malware exists within the network by scanning all files that come through a firewall or a centralized control point that's a little bit further away from the access layer, so that we understand what our overall vulnerability management looks like out there, and then prevent certain traffic flows based on that as well. We can control utilizing two-factor authentication. We can control based on DNS lookup. And we can also control within the workload by utilizing a virtual workload control capability with IP tables and built-in firewall capabilities. We then need to understand what our vulnerabilities look like out there. And the control and vulnerability management pieces could be interchanged. I cover control first to reinforce the idea that just having the knowledge of what identity is out there is fantastic, but until we have the ability to control and understand what vulnerabilities an endpoint poses to our overall network, we're going to be left behind and prevented from implementing the overall zero trust solution. So the ability to do vulnerability management with a posture and compliance module, for example, utilizing our intrusion prevention systems, utilizing malware detection systems, encrypting the transport between devices, whether that's layer 2 encryption between two devices that exist between two switches, and those switches have some sort of direct connection to one another, or over the WAN or over a private MPLS, for example. And then same thing for virtual workloads, utilizing IP tables, built-in firewall capabilities to understand what they are currently seeing in terms of open ports and whether those ports cause some sort of vulnerability to possibly be exploited within our overall network. Finally, we're analyzing. We're utilizing our SIM. We're using profiling information about what devices are out there, how they're configured, what the best practices are, etc. And then utilizing that information to feed into our identification or radius engine, feeding that into our firewall, and then logging all of that back to the SIM and understanding how devices are interacting out on the network and what their behaviors are. And this allows for us to do automated provisioning and overall automated detection and response. For Smart Building Central, we followed this very model. We had our overlay on the underside of understanding what our motivations and challenges were going to be. And next we'll talk a little bit about policy and how policy interacted with Smart Building Central. But they utilized Identity Services Engine for workforce profiling and visibility. They utilized Umbrella for DNS monitoring. StealthWatch, they enforced with ICE, downloadable access lists, TrustSec, etc. They had advanced malware protection at the network layer to understand files as they traversed over a given firewall, and then prevented the categories of URLs that weren't business relevant, adult themes, etc. Utilizing intrusion prevention and that advanced malware protection, we ensured that as files came into the network or as behavioral analytics indicated that there might be a threat on the network, either from a file or from a given user, those could be blocked. And then we encrypted all transport point to point whenever possible. Now, typically the biggest feedback that I get from customers whenever I have this conversation at this point is, you're talking about a lot of products. You're talking about a lot of capabilities that we can't necessarily implement all of tomorrow. It's just not feasible, both from a budgetary as well as an overall manpower need to make this a success. We can't change our entire approach to networking to integrate with your model, and you don't have to. What this comes down to is it lays out a model that you can utilize bits and pieces of as you're ready, as your organization can take them on, and as you have the ability to administer, log, and overall operate and troubleshoot these capabilities within the network. So the key is to layer security throughout the architecture. While the overall security onion for Smart Building Central was vast, this isn't going to be the bulk of many customers, at least not right now. But distributing static policy onto firewalls, policy that doesn't necessarily change, and dynamic policy with downloadable ACLs, policy that can actively be changed based on what we see as the endpoint's contextual identity and its overall vulnerabilities, that gives us the capability to layer in additional security in a piecemeal fashion. We then exchange that contextual identity across all mechanisms that have the ability to consume that identity into our StealthWatch records, into our NetFlow records, into our firewall records, into our overall DNS resolution to be able to say this user on this device went here and they tried to perform this action, which led to an overall threat to the network, and therefore we responded to it based on an established policy that said we need to quarantine devices that take this sort of action. So step number one, gain visibility. The design principles will hold regardless of the controls and vulnerability management that we're applying here. We still want to understand what's on the network, but we're still going to logically segment them with VLANs and VRFs. The nice thing about dynamic capabilities within Radius is we have the ability to say that a VLAN can be dynamically allocated to a port based on its identity as well. We overlay Radius, DNS, and NetFlow on top of this, and we log. By logging this, it gives us more information to filter down. The challenge is we need a good correlation engine that says these things happen based on these identities and these overall processes. So we need to continually go back, review the logs, and have that influence our overall policy. So what was the journey that we went down with Smart Building Central to do exactly this? Well, we started with lab-based vulnerability. We knew that we would have a handful of devices, regardless of whether this was a greenfield or a brownfield building, that we knew would have to be present within the building. Corporate PCs aren't going to change just because a new building opens up. Phones are not necessarily going to change in their overall behavior, even though the model may change when the building opens up. Same thing for physical iKey cameras, badge readers, etc. that all give us the capability to identify at least what the baseline understanding of a device from the same vendor looks like and be able to identify it to work into the contextual identity conundrum. We then went into monitor mode, collecting as much data as possible on how these devices operate, how they look, and how we could interact with them to ensure that we could identify them as clearly as possible. Because that identity would then be shared throughout the entire ecosystem to ensure that as these devices interacted internally and externally, we understood what that traffic looked like. The question came down to, now, how do we process that visibility? What are these endpoints interacting with? How are they interacting? Because that would help us formulate a plan. Utilizing the lab first, starting in non-production, giving us the ability to gather that information, create a policy, minimize vulnerabilities, and enforce that as much as possible. Wash, rinse, repeat. So the most common mistakes that I see customers go about with something like this, well, honestly, are numerous. So the first one is, I have had a number of customers tell me before, we know how all of our systems interact. It's relatively simple. We know that they interact on these ports with these external systems with these capabilities, and that's it. But when we start to do the contextual identification, we now build in traffic gathering and understanding what that traffic looks like out on the network. And when it comes to just the 500 endpoints that we had, or 500 users with 3 to 4 endpoints, so 1,500 endpoints within Smart Building Central, we came up with 145 different classifications of devices. Now, each of the cells that you see within this spreadsheet is a set of ports and protocols for each one of those 145 different types of devices, which means that any one device could be interacting with only one other device, or could be interacting with 10, 20, even 100 separate devices, as you can see with the green cells there. Now, the challenge that you run into is now it's almost like information overload. I know so much about my network and I need to classify it and I need to analyze it as much as we possibly could. So now I need more than 5 to 7 groupings. Now, let's take a step back and let's talk about groupings for a minute. Groupings are essentially the way that we used to classify endpoints into VLANs. We used to say, I'm going to put these devices on a voice VLAN, I'm going to put these devices on a data VLAN, these devices on a guest VLAN, etc. But eventually we started to say, you know what, in the data VLAN, I may have corporate devices that are PCs. I may have corporate managed mobile devices. I may have voice devices that are also video enabled and others that aren't video enabled. And what it comes down to is we want to broadly classify, as I said, 5 to 7 groups, so that we can then, within those broad classifications, break that down into more detailed classifications and better be able to apply policy that is both common to the broad as well as more specific to the smaller without boiling the ocean. Because the best way that we can go about this with Cisco technologies is utilizing security group tags. A security group tag is the ability to, at layer 2, similar to the VLAN header, utilize the unused 16 bits within the frame to apply an identifier and write policies based on that identifier, which is the entire concept behind Cisco TrustSec. So when it comes down to analyzing what those 145 devices looked like and how they interacted with every other one, we knew it was going to be information overload. What it came down to is for one 24-hour period, we were talking about almost 90,000 flows between these devices. With that in mind, 2.6 million flows over the course of 30 days, how is an operations engineer going to differentiate between an IT PC and a finance PC if we apply different distinct policies to each of them and put them in their own unique group, scaling up to that 145 by 145? It starts to kind of look like a whole bunch of ones and zeros if we don't simplify and then educate while also expanding down into something more discrete. The other big mistake that we get a lot of times is Our customers tell us, hey, we know all the devices, we know all the users, and we know that they're all within policy. And my next question to that is, do your users know that? Do your users understand what your overall policy is? Because to be honest, corporate endpoint managers give a false sense of security. It gives us the ability to say, hey, I have all these devices out there, but what about that cell phone that's on your guest internet, logged in with a username and password from a corporate user? How is that interacting with your network? How do we know that someone didn't bring their own PC and with a little bit of Google searching configure their own supplicant to be able to use PEEP with a username and password just with their own machine that is completely against corporate policy? What about smart devices? If that smart device couldn't actively identify itself, do we know that it's on the network? Have we done any analysis for what may be connected to the network on an overall connectivity favored network as opposed to a security favored network? The question comes down to what is really connected and where. And then, just because a device is up to date does not necessarily mean that's behaving as expected. Going back to the camera use case, just because a device is behaving as is up to date doesn't necessarily mean that I can't pull up the camera feed and see it from any PC on the network with the default credentials. The firmware may be up to date, but if the credentials are admin, anybody's going to be able to log into that, again, with a very simple Google search. Now, that leads into one of the additional challenges that we run into, is we have a lot of customers who say anyone can purchase a device and add it to the network at any time. Well, this really yields the need for a onboarding policy, a consistent policy that can be applied across all endpoints and ensure that we understand what the device looks like, what access it's going to get based on its contextual identity, that who, what, where, when, how, and its overall threat network. So, threat to the network. So now when we need that consistent onboarding process, we need to develop something that gives us the ability to identify, and therefore, based on that identification, what capabilities do we have to control it? Based on both the identity as well as the vulnerability management, what information did we get, and how do we prevent this device from being exploited or having an overall larger blast zone or impact to the network if a nefarious actor has introduced it into the overall network? And then, hey, we can't do this on the timelines that we have. This is, again, a massive endeavor that you, Patrick, are saying to us we can do, but we have really quick projects that we're trying to knock out on a regular basis. We're understaffed, those staffed are overworked, but we still want to take the first steps on a zero trust journey. So every journey has its first steps. Let's talk about how you can get started. Again, we go back to what we were talking about before. The crawl, walk, run need for introducing additional capabilities onto the network. In other words, don't expand beyond your operational abilities. You're looking to gain visibility, for example. Understand what those devices are with radius and with some sort of network access control solution that isn't implemented in any sort of enforcement mode. Understand those devices on your network. Once you understand those devices on your network, as the next budgetary cycle comes around or as the next free period comes around, now understand how those devices interact with one another. It may extend out your journey, but at least your journey is moving forward. Remember, it's a journey, not a destination. And then add layers to the overall basics. If you already use VLANs, but you don't use VRFs, try breaking those VLANs into segmented areas that are all prevented from accessing other VLANs that they may not need access to unless they go through a firewall, an east-west type lateral firewall with policies that dictate what that looks like as opposed to routing your VLANs everywhere. Same thing. If you're commonly interacting with the outside world, well, understand what that outside world interaction looks like with DNS monitoring, and then prevent some of those categorical needs from being accessing the outside world and those resources that aren't necessarily needed. When we talk about implementing this, we're typically talking about phases of implementation, and I've been kind of referring to that throughout the presentation here. Start in some sort of open mode, a visibility mode. Understand what those devices are doing on the overall network first. Then do some sort of enforcement between your VRFs. As I talked about with a firewall, you can prevent VRFs that contain VLANs that have no need to interact with one another, but still allow for exceptions to the rule, a whitelist approach, by applying policies via the firewall. And then start within your overall VRFs as well. Eventually this will move down to the VLAN level, and it's working towards the individual endpoint and controlling that individual endpoint based on the information that we're gathering about it. Now, the one nice thing that I've already kind of mentioned here is utilizing a radius solution like ICE to apply VLANs dynamically. Validate that this endpoint is on the right VLAN for the operations that it should be performing. You could also use downloadable ACLs, a dynamic ability to prevent that device from interacting with areas of the network that it shouldn't be based on its identity, and then move towards a layer 2 segmentation ability with security group tags. For those who have tried to administer private VLANs or MAC-based ACLs, we can tell you it is an absolute nightmare to try to implement that. So instead, move towards a dynamic capability where you can modify the packet header and prevent access without having to actively change your ACL or add in thousands more VLANs just to control those endpoints and how they interact. Essentially, automation is going to be that ultimate goal. Prevent your users from taking manual actions to free them up to work on other policies, other operational pieces of the network. Give us the ability to dynamically provision and utilize machine learning to influence policy. And then we can quarantine on action where we do need to manually influence how an endpoint interacts with the network. So the question at this point is, well, is Smart Building Central still out there? Absolutely. They're continuing on their zero trust journey. One of the pieces that they found has been the most challenging for them is that onboarding consistency. The onboarding consistency that we implemented is any new device that's never been seen on the network before automatically gets quarantined into a VLAN that has very little access whatsoever. Therefore, they have to take it to some sort of Genius Bar or some sort of help desk or lab-based area to introduce that device onto the network, gain visibility into what it's attempting to do, and then operationally authenticate, authorize, and profile that device. Their procedure and policy is also constantly evolving. As new endpoints come onto the network, as they're purchased for the network, we need the ability to onboard consistently, but also be able to identify what those devices are before we statically classify them and work around the implementation techniques that we've used to prevent that overall vulnerability being on our network. And then log analysis and automation. Smart Building Central has a ton of tools to crunch all of that noise into Signal and say, here's what you need to be most concerned about, and here's how we identify or address what those identities are and what access they should be provided. Now, as one of the final greatest mistakes here, I have a ton of customers who said to me, listen, my endpoint is never going to work with me to change endpoint policy, to push the supplicant, to give me the ability to authenticate endpoints onto the network. And we don't necessarily need to. It's ideal, but there are workarounds available as well. All we need is Identity Services Engine and an Active Directory machine account. It's what we refer to as Easy Connect. It's the ability to integrate our identity and access solution with an integration into Active Directory to say, hey, I just found this device that came onto the network without 802.1x, but we know that it had to do DHCP, DNS, and login via Active Directory. If we have those credentials that had to authenticate against Active Directory, there's also a log in Active Directory, possibly on your domain controller, that this user logged in. So now we utilize our identity and identity implementation to query Active Directory to say, I have this device that just logged in. You have anything that looks like this, possibly has this MAC address, and logged in at this given timestamp. And by doing so, we can now identify that, hey, that was the user, and change their access to provide them more dynamic access, even without interacting with endpoint teams that may also be very much overloaded. And then, hey, my workforce has shifted to mostly remote. Let's face it, I'm remote in North Carolina right now, even for those of you on site in Texas. How can I apply this to my remote medium? Well, your remote medium needs all of the same things that your physical mediums are going to require as well. You still need that flow visibility. With that flow visibility, you can utilize that to better modify your policies and give you more information on what you can offload to local internet, as opposed to sending over your WAN to a centralized data center that may be consuming more throughput on your interconnection links. We can do dynamic authorization even over the VPN medium, and then we can gain visibility for remote access with the same outcome. We can still understand what the network traversal, once that device has remotely connected to a VPN termination device, that it's doing. We can understand what the DNS lookups look like, what any file trajectory as it migrates throughout the network look like, and it gives us more oversight into compliance. So, to briefly wrap up, let me bring you back to the 3 points that I mentioned at the beginning of the presentation. First off, most of our customers have been working towards zero trust for years. I think I illustrated this with a bit of conversation around your VLANs, your VRFs, your firewall policy. Now you can overlay identity, utilizing radius, utilizing DNS, utilizing NetFlow. Zero trust is an evolving process. That onboarding process is going to be a massive change for many companies who have been focusing on just get the connectivity, don't necessarily worry about security. That change alone can make a massive difference in what capabilities a user has when they get on the network and what ability you have to identify those users and what devices that they're currently on. And bottom line, start with visibility. Understand identity. Understand the interaction outside the network. Understand the interaction inside of the network. Develop a policy based on that. Enforce that policy based on the potential vulnerabilities that are pertinent to the network. Again, I'd like to thank you for attending this presentation. I'll be in the Discord during the presentation here to answer any questions that you might have. And again, if you have any questions at the very beginning of the presentation, go back, hit that QR code, feel free to send me an email.